For anybody that's been following along on previous videos, and for anybody new to my videos, this is a battery backup system I built for my house. And recently I started looking at it from a different perspective and realized that you should design your system with safety in mind, as well as something came up as I was looking at the system, and I realized I should touch on this subject. This system has two sets of batteries in it. The original set of the 314 amp hour hum sinks on the bottom shelf, and a second set of the high sincere 100 amp hour 12-volt batteries on the second shelf. The bus bars on the bottom of the cabinet, I'm not so concerned with. I'm going to just fabricate some covers to go over each one of those. The main negative of the battery pack is on the left side. The main negative or positive on the battery pack is on the right side. It gives a good distance across those two terminals that would inherently prevent small tools or just under normal maintenance, your hand coming in contact across both of those posts and potentially presenting a shock hazard or a short circuit with your tool reaching across the 48-volt battery bank. The second set of batteries, I was more concerned about fitting in the space as efficiently as possible. Originally, this cabinet was purchased with the specific dimensions of the 314 amp hour batteries fitting in it efficiently. The high sincere batteries were purchased as an afterthought once I realized that the 100 amp BMSs in the HumSync batteries limited the inverter's output to consistently provide heavy loads, since they only can provide 100 amps at 48 volts. You're basically limited to about 5,000 watts of consistent load on that inverter, which is capable of substantially more, and surging to more than twice the inverter's output would definitely overload those BMS and either damage them or cause them to shut down. So the second set of batteries was ordered because they were such a good deal in December, to add surge load capability, as they have an internal 100 amp BMS as well. So I tried to pack them as efficiently as possible in the shelf. So the orientation of the cells that I chose to use sets your main battery pack positive right here. And then the batteries go down in series, cross over, and come back this distance direction to the main negative of the battery pack. Well, you can see that presents a bit of a dangerous situation here, as these two terminals on the battery pack are only about 2.5 inches apart. 48 volts DC is regularly considered safe to work around with dry, bare human skin. And generally, it's not necessary to wear high voltage gloves to work on. But a 48 volt lithium iron phosphate battery bank fully charged can exceed 58 volts DC. That, coupled with the fact that as you're working, your body perspires, you have a little bit of a salty layer on your skin, and your finger can easily reach across that positive and negative battery post, which actually occurred as I was installing the fuse holder. I did not receive a huge shock, but I felt the tingle. This having occurred made me realize that not only should you package your system and design your system for efficient use of space, but you should also take into consideration designing your system to be more inherently safe to be around. Some homes may have, children with small hands that like to poke in areas, or even just for general maintenance. You can see how I designed my system, thinking efficiently and used to working with items that are packaged tightly in aircraft. I put the fuse holder right next to the main positive and negative on this 48-volt battery bank up here, and created myself a potential to receive a shock here, or easily drop a tool across that. And what can happen when that occurs. So what I am going to do here, I received some other things that I ordered to go ahead and be able to finalize the wiring to connect my chargers in the system. I did order finally a meter with the shunt to connect up into the main power cables going to the inverter, so I'll better be able to record and monitor the system and have a overall percentage battery indicator for the system. But I'm going to take this opportunity to redesign the layout and reconfigure those batteries on the second shelf to move the main positive and negative physically further apart from each other to eliminate this potential short circuit and electrical shock hazard that does exist. And I advise everybody else to at least take this into consideration. Everybody's situation is different, but if you do have the space, which there is space on that shelf there to reconfigure these batteries, then don't worry about making the shortest bus bars that you can or packing them in the smallest cubic space that you can. Take into consideration also the physical layout of those batteries to just design into your system a little bit more safety, that it would be more difficult to actually reach across the main pack positive and negative and have an incident occur. So once I'm done doing this, uh, then I'll go ahead and begin the final wiring of for the chargers. I did order some connectors, pack of connectors that I can use to connect the chargers up to. I'm going to mount the chargers on the back of my of the cabinet and feed the wires through and put a bulkhead connector on the cabinet with an exterior connector that plugs into it, so I can remove those chargers or reconnect them again just by physically disconnecting them from those plugs. And I did also order a package of inline fuse holders, so that way I can put those in line as well with those battery cables coming from the chargers down to the batteries. And then eventually I will also be, like I said, installing the meter that I purchased. And this is just basically one of the meters that you can find anywhere online. It's got a 500 amp shunt with it and a pretty standard digital meter that several other YouTubers have reviewed on there, and they're all pretty much have the same setup and seem to perform really well for the price. These vary up and down, and you can usually, as they said, find one on sale. And I was actually able to find one of these online earlier this week for under $40, and so I went ahead and purchased it. I'm going to go ahead and begin disconnecting the wires to this battery bank and removing the bus bars so that way I can reconfigure the battery bank and eliminate this potential shock or short circuit hazard. I've already turned off the battery disconnect switch for the HumSync batteries, so that way the Hisense and HumSync batteries are no longer in parallel. And now I'm going to go ahead and disconnect the wiring from the Hisense battery bank. I'm going to remove the bus bar from the middle of the battery pack. That'll separate the pack voltage in half. Removing the bus bar from the middle of that pack now opens the electrical connection. So now there is actually no electrical connection between these posts anymore. So I've opened that connection on the battery. I'm going to go ahead and disconnect the main positive and negative off of the battery. And since previously these leads were connected to the battery bank and they were connected directly to the inverter, I'm going to go ahead and see if there's any charge left in the capacitors of the inverter by discharging that. It's just got a simple light bulb here. And you can see there was still charge in the capacitors in that inverter. So there was still over 50 volts on these wires going to the inverter. So that's something you need to also remember when you disconnect wiring from a system connected to a large inverter. They have a massive capacitor bank, and they store energy for quite some time. You can see the leads are disconnected. And I just wrapped some blue painter's tape over the ends of those terminals just to give it a little bit more protection in case it bumps against anything. That they are discharged now, or the voltage shouldn't be a high enough potential to cause any damage. But it's never a bad idea to put some type of cover. Even just some blue painter's tape is better than nothing if you don't have any electrical wiring tape to insulate those for now while you're working on the system. I'll remove these remaining bus bars. Now that those leads are disconnected, I've removed the 150 amp fuse from the fuse holder as well. That'll further prevent any accidents from happening while I begin repositioning these cables around on the battery. While I'm in the process of reconfiguring the battery bank, I'm going to have to re-terminate one of my connections. The battery shut-off switch that finally came in for the high sincere batteries. You can see the bolt size is much larger than the size that's on the terminal currently on this main positive cable. So I'm going to have to cut off that terminal and replace that with the proper size terminal for the bolt that goes in that switch. Something you want to make sure you watch out for when you terminate your uh, terminals on your cables and put heat shrink on, you want to make sure that the heat shrink does not protrude out underneath the contact area. Will Prowse and several others on YouTube are very good at pointing that out. And when they take apart batteries and they find that the heat shrink is actually underneath the contact area of the terminal, they'll trim that back to make sure they have a positive connection. But that is something you want to watch for to make sure your heat shrink does not extend into the contact area of your terminal. Okay, so we're making some progress here. We've got the cable run across there, and we're going to have to make a new jumper from the switch to this battery post. So we have a smaller terminal going to a larger terminal for that battery disconnect switch. All right, the configuration, we have it now. This is the main pack positive here. The first bus bar is going to jump across from the first battery to the second battery back there. You'll come forward. I'll have to fabricate a new bus bar to make this jump across this long distance now. Go back here from battery 3. There'll be a bus bar from battery 3 to battery 4. And then this will be now your main pack negative. So now your main pack positive and main pack negative will be over a foot apart. Any potential to short a tool would only be across these two batteries now, or a finger. 24 volts is safe. Even at a full pack charge voltage, you would not be able to receive a shock through your dry skin over 24 volts. Having the additional space on the 48 volt pack is a little bit safer, and also the impact of actually shorting a tool across that, while it still would be potentially damaging and quite scary, uh, 24 volts would be much different than shorting across the 48 volt pack. So that's going to be the configuration as we go forward here. And fortunately, the bus bars from the previous battery bank configuration still reach because when I measured the distance with the battery packs the way they're oriented before and changing them this way, they actually would reach end to end or sideways. And so right now you would have these two bus bars go in there. And the third bus bar now is no longer needed. Like I said, I have to make a longer one now that'll span this distance instead of the original configuration. All right, I've completed reconfiguring the battery bank, and now the battery's main negative is on this end of the pack, and the battery's main positive is on this end of the pack. I feel like having them separated like that is a little bit more, provides a little bit more inherent safety into the design of the system, and everything is tightened down and connected. I've made a new bus bar out of half-inch copper pipe, and I know some people are fine with that, and I know some people have issue with that. But I can guarantee in previous testing where I was drawing 150 amps on the system, well, actually, I was drawing 168 amps on the larger battery bank. That uses 3/4 inch pipe, and there was no heating of the bus bars. And previous load testing with these high sincere batteries, I was drawing 80 to 90 amps uh, from the pack consistently with no heating of the bus bars as well. So they seem to be adequate uh, for the loads that they're going to see. And eventually they may be replaced with flexible cables. But since it's a stationary system, it's not really so much of an issue. If this was in an RV, absolutely you'd want to use flexible cables between your batteries because there's always going to be some relative motion bouncing down the road, and you'd need those connections to be able to move. But in a stationary system sitting on the shelf, a solid bus bar uh, will be just fine and are used in many cases in the industry. One of the uses that I found for these little connectors that have become really the in thing right now. I know people are using them for their home wiring, which I don't agree with, but you'll see people use these little connectors that mechanically connect down on the wiring, and I think they're a good option for making temporary connections like this, where you're going to connect wiring or disconnect wiring intermittently, uh, depending on what's going on with your system. And so I find that those connections make a great positive and negative connection on the end of the battery bank. This balancer here, I can remove and swap over from one pack to the other. Right now, I'm just keeping it connected on the high sinceres. I'm going to do a little bit more charging and try to balance these a little better. But you can combine the two wires that go in between the batteries since they're uh, basically work together as it is. So I just put my connection for the two batteries in between the two packs. Always put your plastic connector, plastic insulator back on your terminal whenever you disconnect these and reconnect them, so that way only one of them are exposed at a time. Because once you connect one of the wires up on this battery balancer, then all of the wires are live. There's some power coming in and out somewhere. So that just makes it super easy to connect them up now. So that way you just have a terminal on the three interconnects, the cell battery interconnects, and then the main positive and main negative just go into those little quick disconnects. And there you go. So the balancer is hooked back up again now. So the pack voltage is pack's reconfigured to have its main positive and negative on opposite ends of the bank now, which I feel just provides a little bit more safety. We can check the pack voltage overall, see what we're reading. Right now we're at 53.3, 53.4 volts. I still do have the fuse removed from the system. So we can go ahead, right now the battery disconnect is turned off. So we can go ahead and put our fuse back in. And now with this new fuse holder location, not directly next to the positive and negative, main positive and negative connection on the 48-volt pack, it provides a little bit more safety while you're working around it. Got a 150 amp Victron fuse. These are the ceramic fuses. They're higher temperature. Never really liked the idea of a fuse encased in plastic. Made no sense. And so I spent a few extra dollars and bought these ceramic encased fuses that are, to me, a much better idea to take heat and are going to be more likely to survive a failure. So we'll get this tightened down. And you can see I'm nowhere near the main negative and main positive of the pack now. It gives me a little bit more clearance. They're the highest potential you're going to see across any of these two junctions now. There's 24 volts between these two terminals, 24 volts between these two terminals, and 24 volts between these two terminals. The only location on the battery where you're going to see 48 volts is actually from the two ends. So it just makes it a little bit safer that obviously that tool is not going to reach that, and you're going to be less likely to put your hand on each end of the battery. Now, the last thing to do before you turn on your main battery disconnect is to pre-charge the capacitors in that inverter. I could either do that across the shutoff switch for the HumpSync batteries, or I can do that across the shutoff switch for this. Eventually, I am going to wire in a switch with the light and wires on the cabinet, so that way I can pre-charge the resistors without having to do this. But this is still the system's in its redesign phase, I suppose you could say. So all you have to do is you put your light on one side of the shutoff switch, touch your wire to the other side. You'll see the light, and that's actually the current flowing through. This is a 115 volt AC light bulb. It's just a generic light bulb, and that slowly charges the capacitors in the inverter prior to turning on that switch. So that way you don't get that huge surge current. It's not really great on electrolytic capacitors to do that big inrush surge like that. And it's definitely not great on these cheap battery shutoff switches. I turned on the switch a couple weeks ago on the other battery pack without pre-charging resistors just to see what the result was. And the switch smelled a little bit. It made a popping sound. It works fine still, but I'm sure if I took it apart, there's definitely a pitted area on those switch contacts now. So now that I've pre-charged the capacitors, I can just go ahead and turn that switch on, and the inverter is live. So now there is 48 volts. Well, actually, there's like 53 volts we measured going to the inverter. And so we can actually go and check and see if the inverter does turn on now. And there you go. The inverter's back up and running. Display showing 53.1 volts on the display. And there's no load on the inverter right now because nothing's hooked up. So that's it. So to me, that's a safer way to have your battery pack configured. And I should have honestly looked at it from that perspective when I was originally setting this up. But, you live and you learn. And like I said, it was more compact. I had a little bit more shelf space to do other things in there. But I feel a little bit better now having about 1.5 feet between the main pack positive and negative compared to having 2.5 inches between those two terminals. So that's it for this one. And I hope everybody has a good day.